So welcome. This is one of our residential building technology sessions, and today we're going to be talking about approaches to air sealing. First, we're going to start off about the work that we're doing and that we're carrying across Alberta. We commit to respecting and upholding the values and traditions of Indigenous communities who have lived and continue to live here. Alberta Eco Trust, we operate across all of Alberta, so we recognize the traditional territory of many diverse Indigenous people. This includes Treaty 6, Treaty 7, Treaty 8 nations, the Blackfoot Confederacy comprising the Siksika, Kainai, the Piikani First Nations, the Cree, Dene, Nakota Sioux, Saulteaux, and the Métis Nation of Alberta. For those that may not be familiar with Alberta Eco Trust, we are a foundation. We are a charity that leads and supports environmental and climate action projects across Alberta. We were founded 30 years ago by environmental nonprofit and the oil and gas industry. We have partnered with often unlikely groups to help mobilize environmental action. Our programs include grants. As LC3 founding member, we have endowment that allows impact investing. We help run programs where there's a gap in industry, such as our HUP program, ENBIX and the Retrofit Accelerator, and we're well known for our strategic engagement. So I mentioned two programs there, so ENBIX, who you're going to be hearing from our team here today, and the Retrofit Accelerator, looking at obviously retrofits and how we're helping with coaching services there. ENBIX, the Emission Neutral Building Information Exchange, really a collaborative initiative across Alberta Eco Trust that we're trying to bring building industry together, from developers to builders to trades, to help build capacity and support building and renovation practices across Alberta. The goal is to reduce emissions from new and existing buildings across Alberta. So these are one of the events that we put together. We host many events. We share resources, develop and strengthening skills of people and organizations through training, peer-to-peer learning, and communities of practice. The Retrofit Accelerator is a free coaching program designed to guide building owners and managers through sustainable building upgrades, known as deep retrofits. These take a whole building approach to standard upgrades to reduce emissions, energy consumption, and operating costs. And we're partnering on these sessions today with SSRIA, and I'll let Pam speak a little bit to that.
Awesome. Thanks so much, Juan. So SSRIA stands for the Smart Sustainable Resilient Infrastructure Association. And our focus is to accelerate adoption of low carbon innovative solutions in the built environment. So to reduce, so basically applying innovation to reduce GHG emissions in our buildings. We are a not-for-profit member-based organization, and we're really focused on collaboration, which is one of the reasons why we work a lot with ENBIX and kind of moving forward this vision of emissions neutral buildings in Alberta. Part of the work I think that might be of most interest to those on the call today is our demonstration project. So we have funded and continue to fund demonstration projects of innovative technologies to be able to validate those in an Alberta context. And so interestingly enough, even some of the technologies that we're going to talk about today, or the solutions we're going to talk about today, have been part of demonstration projects, namely the Aerobarrier product that Darren will be touching on. So all of the information and the data from those projects are available on our website. So if there's something that you hear that you're interested in and want to learn more, you can certainly head over to our website at sria.ca and get more details on those projects. And I think I'll leave it at that. Thanks, Juan.
Thanks, man. So Zoom poll, we run a efficient and tight ship here. So thank you everybody who put input into that. So we're talking about today's panel. So myself, my name is Juan Monterrosa. I am the program manager for ENBIX at Alberta Eco Trust. And we have three people here with us today. Ben Ethier, who's with Mattamy Homes, Darren Huckabay with Aerobarrier, Ecosynergy, and Brandon Hansen with SIA. So, we're going to talk about air barrier, and I think there's one of the things that we've been hearing a lot of, and I think especially now with new building code coming out and the tier code are kind of why air barrier. There's been multiple sessions kind of over the past few years going into like the details of the thermodynamics of it and the reasoning why. One of the things we want to talk about today is, talking about the importance of it. So, meeting the current code, how the current ones mandate specific air barrier performance, the levels and the quality of it, energy efficiency, how air barriers are important to energy efficiency. Speaking to comfort, looking at reducing the amount of drafts and cold spots, as some people may have felt over the past week. Durability of buildings and the walls, so trying to prevent that moisture from entering the wall assemblies and having the risk of mold or any structural damage, which also obviously leads to like indoor air quality. So reducing that air leakage to help filter out any pollutants. And if you're getting some of that mold in there, then obviously you don't have the greatest air quality there. A bit on, I guess, like the more technical side of it is we hear kind of 3 acronyms that are tossed around in the code. And just when you're speaking about air barriers, you'll hear a little bit about it today from the speakers. So you'll hear ACH, so that's the air changes per hour at 50 pascals. So how many times the air in the house is replaced with outside air under that specific pressure difference. The normalized air leakage. So this one is looking at the size of the house and provides a more of a standardized way to compare the air tightness for different size homes. So I think there's, for those that have gone deep into air barriers, there's, when you look at the total like surface volume ratio and the air leakage number, and there's kind of like a specific point where it works. And depending on the size of your home, it could be easier or harder to hit some of the ACHs that you need there in terms of the code. So something that's still continuing to be obviously worked out through the code evolution, but something to keep in mind. And the other one is the normalized leakage rate. So similar to the area, but this one accounts for the size and expressed in terms of the CFM at that 50 pascals by the square footage of the home. So like, and in most cases for all of these, lower is better. So the higher you get an ACH, the more leaky it is. Same with on your NLA and your NLR. So just like a little bit of background there, we're gonna hear a bit about kind of what some of the common places for air leakage happen. Yeah, and just kind of hear 3 different methodologies at going through and addressing air leakage and air barriers. So first up, we're gonna have Ben from Mattamy to talk about some of the work that they do at Mattamy and how they address air barriers there.
Awesome, thanks. Yeah, I was reminded this morning when I woke up, I got out of bed, put my feet on the floor, and I've got a 1956 house at about 7 air changes an hour. So I was reminded very quickly how drafty it is. I was joking, you couldn't hold a match lit in the house without the crosswind blowing it out. So yeah, I'll give you a quick rundown on who Mattamy Homes is. If you're not sure who we are a production home builder. Originally based out of Ontario. I think the first house Mattamy built was in 1974. So we've been doing it for a while, largely in Ontario. I think the volumes out there are, 3,000 in Toronto, about 1,000 in Ottawa. Here in Calgary, we do about 900 houses a year is what we're expected to do this year. So yeah, production home building is interesting. I think you're going to see some pretty innovative solutions coming up with the presenters after me. But specifically, I think what I wanted to talk to is about how we kind of air seal, how we achieve some of the improvements we do in a production environment. I know initially we had all talked about, discussing poly, but I think what I'll be doing is looking a little bit more at the continuous improvement model. Generally, poly is good, but I think what we found and what I hope to kind of show you guys here is that it's more than just poly. You've got to take a very broad look at the house and really understand what's going on there. To really achieve any success beyond code, you do have to take that holistic continuous improvement approach. We were finding even small little mistakes or imperfections can have some pretty big air change impacts. So I could just kind of walk you through how we did it and how we've been continuing to do it. First thing we did was understand the problem. You don't know what to fix if you don't know where you're leaking. Identifying the opportunities for improvement, figuring out what to do next, how to kind of fix or how to implement those opportunities. A big piece I'm going to show you is our ongoing tracking and the depth that we go on our tracking, and then encouraging innovation, really encouraging our teams to dig in and solve the problems themselves. I can't be the only one as the sustainability manager at Mattamy to solve these problems. Really leaning on the teams that know this work and know our houses inside and out. So again, the first piece was understanding the problem. We really started by undertaking a deep dive assessment with our energy advisor about what we were doing well and where we could improve. Our energy advisor was a great resource in walking us through like all the big issues and all the little minor issues in each one of our products. We did so many of these thermal scans. At some point, I was dreaming in orange, yellow, and purple. So that just gives you a sense of how many of these walks we did. But it was really helpful to track down all of the, hard to reach, hard to find, hard to see areas. A good example here on the left photo is in the middle of one of our thermal scans. You can see when you look at it, it looks fine. You put your hand up on it, it looks fine. But you can see kind of in that back little rim space up against the foundation wall where there's a lot of cold air leaking in. You wouldn't know that without a thermal scan. Another one that was really interesting to me was on the right side here. This is just a regular photo and then a thermal image of the same time, same photo back to back. You can see the bottom one. You can see there's Ecosynergy on the bottom. There's poly. There's no tears. You can see the taping of any patching that needs to happen. Visually, it looks good. When you put a thermal camera on it, you can see exactly where the leaks are. Now, I understand we're going to put drywall up against that. We're going to squish out the Ecosynergy. We're gonna really seal that up. But this to me was just, we walked the houses before and after drywall and saw this time and time again, and you just wouldn't know it without thermal imaging and really doing a deep dive look into these things. So next piece for understanding the problem was doing a lot of on-site inspections and installation reviews. We did a lot of walks with our trades, with our builders to really understand what they were doing at that exact point in time, what they were doing well, and where we could make some improvements. I was definitely accused of being nitpicky more than a few times. I had some people say, what the heck does the color of the tape matter? If I'm taping the joint, that's all that should matter. And I also had a lot of people tell me that's way too much Ecosynergy. There's no way that we can get away using that much. But really, we just persisted. In the end, we came up with a really good understanding of where our houses leaked and where we wanted to focus that time and effort. Our biggest culprits, I think, fairly obvious to anybody in this space, was exterior surfaces, so specifically the floors, the walls, the ceilings. And I parsed out of that the rim spaces because we found that they were very leaky. They took up a big portion of the walls and ceilings space as well. And if you've ever tried to air seal a rim space, it is tough. So I pulled that one out because it was a special focus for us. Next one was any exterior penetrations and windows. So this is probably obvious for anyone in the space, but we wanted to make sure that we walked through it and we knew exactly where we wanted to spend our time. So what were our implementation steps? Step one, just improve the details. I think we knew those 4 key places. We worked with our EA yet again to further improve the airtightness details based on all the findings we got from that research. We also worked to make them easier to read. You can see here, and that was a key thing that we got for feedback from our builders and our trades, was on a black and white drawing, it all looks the same. It's really hard to understand what goes where. So we really worked to highlight the places where we could make those improvements and make things easier for them to read. They're not the specialists at this. That's what the detailing's for, and that's what helps everybody kind of move along with that. The next piece was the training. You can see on my training list on the left side there, it wasn't just the builders and it wasn't just our trades. It was a key part, including builders, the guys who were doing the inspections on site, the trades, the people doing the installs. But it was really important to include our office staff. It was really important for us to make sure they understood the system that we were trying to implement, the implications and the importance of their job in improving the air tightness. The photos here were photos from the half day we spent. It was -30 in an unheated house, just framed up, kind of insulation and poly. And it was great. We walked through with everybody on site, some really good examples of good and bad air sealing, where we could improve. And the key piece was why we were doing it. I think really explaining why it was important to check this or caulk that or make sure this is sealed, and the importance of, you know, a small crack here across the whole house really has a big part to play. And again, we did this with the trades, but without any of the Mattamy staff. We also thought that was quite important to give them a safe space to speak out. If there was anything that we could do better, we didn't want them to hold back and not give us that information. So we did a separate session just with them, without anyone from our staff there, with our EA leading that again. And it was super helpful. Finally, the biggest piece was find and fix before drywall. A good example is in the top right corner there. You see the hand behind the poly. Once you put drywall on top of the poly and on top of the air sealing, it's nearly impossible to find and fix a leak. Finding a leak's a great example. If you see the switch box that's right next to it, well sealed, well polyed. When you put drywall on that, the leak comes through the poly and it probably comes out through the box. You would attribute that leak to the box when in fact it's just unsealed poly joint right next to it. So once the drywall goes in from this perspective, it's really difficult to find and fix. We also took all of the information from all of the training we'd done, all of the inspections we'd done, all of the reporting we'd done to put together a really good inspection template or inspection form for on-site teams to use. Now, I do want to draw your attention to the highlight the headings that each of these are in. And we specifically made the headings similar to the ones that you would have noticed where our highest leaks were. So rim boards, joist spaces, and void spaces, penetrations, they all are exactly the same as where we found our biggest leaks. And that's intentional. We knew that's where the biggest leaks were. We knew that's where our biggest opportunity for improvements were. And then just continuing with the follow-up inspections, you can see we encourage the teams to make spray paint marks when they did their inspections. We encourage our builders to just find and fix these issues on site. And if they couldn't, get the trade back to help them fix it. And then on the bottom right there, we continue to just do our thermal imaging checks and just making sure where we had made these improvements, we were seeing the improvements in person. So this was the ongoing tracking. It's important. Up until this point, we've really been talking about all of the solutions we've had along the way to improve our air changes. That's all fine and great, but if you're not tracking your outcomes, it's going to be really hard to realize where those improvements were and if they've actually caused improvements on site. You can see here we blower door test every single house that we close or that we've closed since July 2022. To date, that's well over 1,500 tests, blower door tests. That's every model, every product, everything we've closed. We have a blower door number. We have a lot of other background data, but that's kind of the important piece here. Another one, it really helps us understand where we're winning and where we're losing, where we can improve. This, what you're seeing on the screen right now, is an example of just our air change reports. Anybody can pull this up at any time, filter by site, by location, by time, by date, and kind of see how they're doing. We also send out a monthly report that's a bit easier to see to the whole division, all the employees, and it had an unintended benefit of encouraging competition. If I miss a report, I find that I'm getting emails and calls from our site guys within days saying, where did I land? Did I win? Was I first? Was I last? How did I stack up? So we're really finding competition between sites to get that air change number down. And then the other thing I wanted to call your attention to is in that top middle bar there. That's our ongoing air changes, overall total average. And you can see a big spike in February. February was when we completed that on-site training, which you'll also see after that spike, which I'm super proud of. I'll explain this to anybody every time. You can see a marked decrease over time, a consistent decrease over time, and a consistent improvement. And that's the win from doing the tracking, is we can show. And as soon as we start seeing that bump up again, we'll do another round of training. It's probably coming up in the next few months anyway. So that's one of the biggest takeaways here is the tracking. You can do all of the work you want, but if you don't know how it's working or how it's improving the actual air changes on site, it's not helping you at all. Finally, the last piece is encouraging problem solving and innovation. We encourage and support our teams who know the problem best to find solutions for that problem. But it's not just finding solutions, it's robust data-driven problem solving. So when they come up with a solution, we work with them to figure out how best to test it on site. We do a lot of blower door testing that's kind of unconventional. You can ask our energy advisor. I think sometimes they're pulling their hair out when I'm asking them to blower door test a single room in a house to see how that room or that window treatment stacks up against all the others. But this is kind of closing the loop again, is now we have we know the problems, we know where they are, getting our teams to help solve that problem, making sure it's not just me, the sustainability manager, but everybody that's bought in and making those changes. So that's all I've got, Juan. Thanks for giving me the chance to chat.
Thank you. Okay, we're gonna be bringing on Darren next. I see there's some questions coming in. We're gonna go through the questions at the end just to make sure we have enough time to go through everybody's presentations.
Okay, we're good.
Yeah.
Yeah. Okay. So yeah, I'm Darren with Ecosynergy. We're an energy consulting firm. So Ben talked about his energy advisor. We do a lot of the similar scope, air leakage testing, troubleshooting, building code, permit submissions through 936, EnerGuide, all that kind of stuff. We got into Aerobarrier back in 2019. A client from Grand Prairie mentioned it to us, and we looked into it and thought this kind of ties in with air leakage. The thing about Aerobarrier is it's an automated air leakage solution, so it kind of takes a little bit of the guesswork out of making your buildings more airtight. It's a pretty simple process. So we get the site, we tape all the horizontal surfaces in the building. So windows, so typically we go into drywall. We would tape windowsills, we cover fireplaces. Ideally, we're in before cabinets. So if they are in, though, we throw some poly over top. Any unfinished floors. We then set up the sprayers, as you can see in the picture. We set up a blower door at the front door. So what we do is we put the building under positive pressure. So all the testing that Ben was talking about is negative pressure test. We create positive pressure. Once the building's up to pressure at about 100 pascals, anywhere between 100 and 200, we mist a sealant into the air. The sealant is an acrylic water-based sealant. And so what it does is, as you fill up the building with air, the air has to escape. Air always wants to balance. So when you have a leak, think of a balloon. When a balloon is full of air, the air just floats around and nothing happens. But when you open that valve of the balloon, the air comes out really fast. So when you have a leak at your building shell, there's a velocity change at that leak, and the sealant that gets built into the air, kind of creating that, we create that fog. The sealant gets pulled to the hole and self-seals the outside of the hole in. So it'll seal everything from about a 1/2-inch hole to a hairline crack. And it's all fully automated. Like, I'm outside at this point having lunch. I go in once in a while, look for some big holes. But Aerobarrier kind of does its own thing because it's letting physics do the work and not relying on humans to find all these little holes. We do drywall in the States. Some of the guys do it before insulation. The problem that creates for us here is two things. We need an air barrier in place, which means we would need the drywall up at the attic because we, for the most part, poly is our primary air barrier. The other issue is heat. Because it's a water-based sealant, if it's -20 like it is today, to try and heat a building without insulation would cost the builder a fortune. So it's kind of it's the simple process for our Canadian winters is just to go in a drywall. The building's heated as long as it's anywhere above 0, but ideally above 10 degrees Celsius. That allows the sealant to do its job. So yeah, and once the seal is done, so we have a live graph, as you can see on the right. So that's a full printout of a seal we did, but the results are all live. So we see the initial air leakage rate, whether it's 3, 4, 5, 10, 12. And then as the seal's going, we can see the dips or see it drop live. And so some of these pictures, so there's one showing it's drywall ceiling to the floor is the top left picture. Other ones are some holes, some cracks, the penetrations. So these are some pipes going into the wall. Top right corner is actually a bathroom for a townhouse project. So that bathroom is on the party wall and it was leaking to the party wall at that corner. Kind of bottom middle, that's a slab edge on a walkout. So a lot of walkout basements, that slab edge, there's nothing in that little hole, and surprisingly dirt can leak. So when you do negative pressure testing, you'll have the air come up through that hole. So under positive, we're pushing the air into the ground. So yeah, so it's a Green Guard Gold certified product. So some people worry about off-gassing, low VOC. So we wear a mask when we're inside the building because it is a sealant and we don't want sealant in our lungs. But typically within 30 minutes of us finishing a seal, we vent the house. Whatever escapes outside is safe for the environment. Like it's just acrylic. It's like a low VOC paint. And there's next to no smell in the house. Like if you open a pail and you put your face in the pail and you smell it, you will get a slight odor from the sealant. But in the house, you will not notice the sealant. They did a bunch of durability testing on it because obviously it's a new product. It's been around, I think it got developed in 2015. The initial product, which is for ductwork, was developed back in the early 2000s. So they had to go to accelerated testing to see how it works over a long lifespan. Once it's in place, it can flex like it does when you scrape it off a pail or you touch it in a hole. It's not tacky. It's got a slight rubberish feeling to it. The results we see, again, we see everything from 3 air changes per hour down to 0.5, 0.6. If you're starting at 12, 11, 10, sometimes we're only getting down to 3. So there is limitations to what it can seal. There are some design limitations to a building. We've had 2 projects here and 1 project in Ontario where the mechanical room opened to outside, whether that's the garage or outside the building. That creates some sort of pressure issue we're trying to figure out. So that there are some limitations to what it can do. Existing homes, so Ben with his 7 air changes per hour, we can obviously help him with that. He's well aware. We did our existing home that we bought about 3-4 years ago, which is a Mattamy built, and it was sitting at 3.5 ACH, and Aerobarrier brought it down to 1.2. So existing homes don't seal as low as a new build because we can't seal the rim joist because it's all fully finished basement, finished ceilings. Later on, we actually spray foamed part of our rim joist in the basement because we had access to it because we had done some other work on the house. Our final test came in at 1.9. So it kind of gives you some idea that where it can get to with existing homes. Like I said, I tell people it's a 50 to 60% reduction. So a place like Ben's, I would expect Ben's house to drop down to say from 7 to around between 3 and 4. If Ben's was a new build, I would say we can get you from 7. We should be able to get you under 2, maybe even under 1. It just depends on what the holes are. If we're dealing with party walls, the drywall needs to be behind the bulkhead. If the bulkhead is directly connected to a party wall that's not sealed, that's where Aerobarrier is not going to be able to seal it. So that's about it. It's automated. It takes the guesswork out of air sealing. So it really helps builders that are at that 3-4 air change per hour that want to get down to under 1. Then this is kind of a simplified solution to get there, making their drywall. It's just an airtight drywall approach that's automated. That's all I got.
Okay. Thanks, Darren. Yeah, I noticed so Ben's answering a few of the questions in the chat and the Q&A. Darren, I think there's one in there for you. And anything we want to go into a bit more detail on, we'll go through at the end. So next, we're gonna have Brandon from SIGA present.
Okay, hello everybody. So my name is Brandon. I've been working for SIGA for about 3 years now. I went to Switzerland to where they manufacture all the products, got trained up by the headquarters there and how they achieve their building kind of philosophy. So what we do at SIGA is we like to think of ourselves as an education company that makes good products rather than a product company that makes good education. So what we like to focus on is the innovation within our products. And in order to stay innovative, we run our own R&D departments in Roosevelt, Switzerland at 2 separate manufacturing facilities. And we have a lot of customized manufacturing to kind of cater to each one of our customers the best way that we possibly can. And then the final thing that we do is our sales and engineering team are very highly trained to give training to builders and to make sure that building practices are staying high efficient. And why we do this is we really try to serve and make what we try to do is strive for a world of zero energy building loss. Okay, so how do we achieve airtightness on the exterior side of it? So the product that I wanted to talk to you guys and what we use for this is we use a peel and stick membrane. So ours, of course, is 500 SA, but there's tons out there on the market like Blueskin. And what it really does is it's a giant sticker that wraps around the building. So you'll see later on in my presentation that we have some penetrations that might get hit during the construction phase. And what a giant sticker around the building does is it makes sure that all of the area is completely sealed, no matter if you have small penetrations. Okay, so how do we identify an exterior air barrier? So what we like to do is we like to follow the red line method. So this one is definitely an interior build, but it's important that in the plan, it is possible to follow the airtight layer of the building envelope all the way around the building using a single stroke of pen and paper. And good designs, you can clearly identify where the airtightness layer will be and how each one relates to the adjacent layer and also how it will work around any penetrations. Okay, so here we have on the left side an interior red line method, and you can see that it goes around here, and this is your classic vapor retarder as your air barrier approach. And this is kind of the classic approach that most companies do as well. But a lot of what we kind of strive for when we use a peel and stick program is we go through the exterior as our air barrier. And that's using your WRB such as Tyvek or your 500 SA or Blueskin as your exterior air barrier. So there's a key couple points that you really want to focus on when you are having an exterior air barrier approach. And this was very touched on by Ben, but the rim joist is very important. So you want to either make sure like during your construction phase that you have a good plan for sealing that area before any sort of canopy roofing goes on. And you want to also make sure that the base of the wall to the ground is really airtight as well. And that it's really important for the Alberta area because you might have a lot of condensation coming up from the cold weather. So it's important that you have the base of the wall really airtight sealed as well. So any kind of support beams or canopy roofs, you want to make sure that you are planning for those ahead of time. And during construction phase, it's easy to make sure that all these areas are pre-stripped. And during a retrofit, if you're unable to get in between these details, you want to make sure that you can seal around them accordingly. Oh gosh. So I just had a Alberta project that we had by Omnia Construction, and this was supplied by Performance House out in Edmonton, and they went with an exterior air barrier approach. So as you can see, this is the job site. And what we really want to point out here is that you can see the seal, how well it's sealed just all the way along the bottom of the building using multiple different products. So we have Suprema, 3M, and of course our 500 SA peel and stick product. But you can also see in the top right corner that the pre-stripped canopy roofing is done as well. And that was obviously planned during the construction phase. So they know that when they come for an exterior air barrier approach, that it's going to be completely sealed all the way around. And as I mentioned before, when we're looking at an exterior air barrier approach, there's a couple key points that you really want to take a look at is make sure that all like the corners are pre-stripped and flashed and make sure that it goes all the way around. But as I mentioned, the busyness of a construction site obviously leaves something to be desired if stuff is hitting your exterior air barrier because you have a lot of stuff going on around the job site. And as you can see in this area, just a small little nick actually happened by someone who was putting up the scaffolding around the building. And so without a peel and stick, you might be a little bit more concerned because you have now you have a giant penetration in your exterior air barrier. However, because you have a peel and stick membrane, no matter what kind of penetration that you have that's actually hitting the outside of the building, it's very easily to be able to be air sealed. And we see a lot of these common builds are coming up to about 1.2 to 1.6 air changes per hour, but we have a lot of people also achieving that with Tyvek. So I think the important thing with an exterior air barrier approach is that you really just make sure that everything is sealed on the outside and make sure that everything is pressure tested and well fitted. And very short, but that's all I really had for you guys. So thank you very much.
Thanks, Ryan. Yeah, great. I think so. The intent of today was kind of give the three different approaches and just kind of get a feel for like what goes into each one of those. I think the questions that came up, and one that's actually interesting, and I think they're both kind of around the multifamily and talking about that that party wall. I know, Ben, if you could like go into a bit more detail. One of the things you mentioned was, you know, because some code considerations, it makes it difficult to go through and reduce that amount of transfer between those. Would that be based on the fact, just like in terms of like fire protection there, of like how you'd be connecting those two? Is that kind of what you're meaning?
Yeah, I think it's kind of twofold. Fire code, I think, limits the amount, like what we can put between those two spaces. We would normally just put poly, be done and dusted. The other one is the actual moisture dew point moisture change piece. Putting poly in a space that is somewhat heated or somewhat accessible to the exterior makes it hard. We're still not certain kind of what goes where. Good example, I think in that last photo I showed you, was trying to put Tyvek in that inter party wall space to see if that worked. Another thing, when it comes to fire code, some jurisdictions don't let us put ceiling electrical boxes. So the ones that have the foam seal gasket on them, some jurisdictions require the metal boxes, which are just going to be harder to seal. So there's a few bits and pieces like that that make it harder. I can say with almost 100% certainty, that is the difference between the detached and the attached. I mentioned we had done some testing. We did a guarded blower door test where you're essentially blower door testing all 4 doors in that multifamily unit, essentially pressuring the whole envelope up to 50 PA. We saw a really low ACH. I think it was like 1.5 in that building, whereas the in between individual units were up around 2 and 3. And we saw a lot more leakage on the interior units, which would have 2 party walls, versus an exterior unit that has 1 party wall and three exterior walls. So we're really certain about that. Now it's a matter of trying to figure out, you know, how best to do it, how best to go about working it. So.
Great, thanks. And Darren, you're kind of mentioning is like that's where you would kind of see where you would come in and provide like a solution on that end, right? Like to seal up essentially that connection.
Yep. Yeah, because again, wherever the drywall is, that's what it'll seal. Where we do see, so I had back-to-back townhouse projects, one in Calgary, one in Canmore, about the same size. The ones in Calgary started at 9 to 12 air changes per hour. And a lot of that leakage was because as a sequencing issue, the bulkheads were put in before drywall was put in on that party wall. So that bulkhead is a massive hole. And there's in these units, there's no poly on the party wall. The party wall is just left. The air barrier on the party wall is the drywall. So that one started at 9 to 12, but the next builder in Canmore, they had their drywall behind all their bulkheads. They were starting at 3.5. So there's a big, just sequencing on those party walls makes a big difference, on top of trying, you know, like Ben's concern about vapor, having Tyvek there is vapor open. So now you can let the mechanical system take care of that vapor if it does flow from one unit to the other, instead of having poly trapping it. We've been having the same conversations as energy advisors and stuff about what's the best 2 materials on that party wall. But a lot of it's penetrations. Most times it's penetrations, and bulkheads are the big leaks that I see on party walls.
I also think it's important to note too, from like an energy efficiency greenhouse gas improvements point of view, we did the thermal imaging checking of the, on our exterior walls, we did a check, we did the blower door test and the thermal testing when it was -20 outside. The air coming in from our exterior walls was 7 degrees. That's cold. That's a lot of air you have to reheat. The air coming between the party walls was 20 degrees, somewhere between 18 and 20 degrees. It's a lot less differential to heat too. So I'm not saying, we don't want to focus on the party walls, but from an energy efficiency point of view, it's a lot easier to heat 20-degree transfer air. And there's other pieces that come with that too. Smell transfer, all of that. So smoke transfer. So it's important to focus on it. But yeah, it was just interesting things we've learned along the way. I'm new to this, so it was interesting to see.
And then Brandon, on your end, like when you're looking at it, obviously like everything on the outside, if it was, a multifamily, you're wrapping all of it, but then looking at having something either be like, would you look at something like a product that would be vapor open, I guess, on that party wall, or like,
Yeah, so we do see like products that are used that are vapor open around there, but like the majority of it is like when we use the peel and stick on the outside, like that's the majority, because we try to have products that have like a high permeability as well, and then we seal it with a tape that is a little less vapor open. So yeah, that's pretty much how we take care of that.
Okay, yeah, I saw Pam put a link in the chat about one of the projects there that was mentioned as well. One of the comments was metal boxes with putty will also air seal well, and I think that's kind of what you were mentioning there too, Ben.
Yeah, they do. It's just different. It's another thing to learn, another way to learn how to do something. And you really have to focus on getting the putty right, getting the sealing around it right. So it's just something that's different, and anything that's different is you got to relearn and reteach, and there's an opportunity for error. I think from the traditional air sealing piece, a lot of it is how many times you can repeat it and get better at it. That's the key to the poly and the traditional sealing.
Well, and even the wires coming into those boxes, right? They have that little groove in the middle. So if you have 2 or 3 wires coming into a box, each little groove is a leak if the wires are all sandwiched together. So now, are you going to putty in? Are you going to pull every wire apart to make sure that you get putty in between each wire, or spray foam, or whatever the material is?
Yeah, I've seen actually details where people have maybe 3 or 4 wires coming through, and then they use like a vapor diffusible tape on each layer of the, I think each layer through the wire, and they kind of wrap each one around to kind of make it one wire singularly through. And then that's when you would add putty on the outside.
There was one about, do you do a positive and negative test to confirm on the Aerobarrier?
The test everything is all done under positive pressure. So the initial test, so there's always going to be a difference between positive and negative pressure. And plus, on top of that, we tape off, I forgot to mention, we tape off the windows shut, we take doors shut, like attic hatches shut, so those things will leak after. So our test is positive beginning and end. We've done follow-up testing with negative pressure. Typically, there's a difference of 0.3 to 0.4, but our tests with the system as is positive all the way through.
Okay. So I'm just sharing the QR code for the session. I'll just wait if there's any other questions kind of popping up here in the next little bit, but just appreciate all of your time here today. So yeah, the QR code there, these sessions are continuing. The next session is on Windows, more than a view, considerations for window design and installation. So talking about efficiency in Windows when it comes to heat transfer, and also speaking a little bit about cooling loads now with 936 speaking to cooling loads. And we'll be hearing about installation as well. So actually it'll be Darren who helped Ben out with some of the checklists, and he'll be talking about installation and how to properly install those for weather barrier, air barrier, and just making sure that there's dryability there as well. So keep on the lookout for that. And lastly, a geo-exchange webinar coming up as well on February 19th. So you can take a look at that and register if you're interested in hearing about geo-exchange in Alberta.
I think there was one additional question from Diana.
Oh, let's find it here.
Says, Ben, did you test the units where, oh, he's replied.
Was just replying, but hey, that works. Yeah, the question was, did you test the units where Tyvek was installed between the party walls? We did. They were slightly worse than our running average of 1 year. But that's not to say Tyvek doesn't work. You're comparing a very small sample size of 2 units to a very large sample size of, you know, probably 700 or 800 multi-units that we had done. There's also, when it comes to air tightness, I think I harped on how many different variables there are when you're looking at traditional air sealing tactics. There's many confounding variables. It's not as easy as just saying the Tyvek worked or didn't work because it had a higher or lower air change. We're kind of in the process of working through doing an actual full report on whether that does work or not, or how well it works, whether the Tyvek made sense. Generally, I think what we look at on the party walls is just the next thing we're looking at is giving someone spray foam and Ecosynergy and a Friday afternoon, and see how tight they can get a house with an afternoon of just elbow grease and hard gritty work, and see if that does it, because that might be our solution. That might just be the way to do it. So I hope that answers your question. It was kind of a non-answer to a question, but I don't really have the answer. It was slightly worse, but with an asterisk next to it.
Well, again, thank you to the 3 of you for coming in and speaking today, and thanks to everybody for questions as well. Yeah, just getting a feel of like the type of questions that are out there, and this really helps out on our end at ENBIX, just to know like the type of resources and tools and additional training that we could continue putting out, and how they evolve with the comments and feedback that we get back. So that's why your comments are always very important at the ends of these. So please take a moment to fill that out for us today.